Students, am I audible to you? Please confirm. Please confirm if I'm audible to you and if my screen is visible to you as well. Okay, very good. So welcome everyone to today's session for this week. First class is for Unit 5B. Okay, last class we already saw Unit 5A. Yes, very good evening to everyone. We had seen fertilization, gametogenesis in the class. So we are going to discuss few questions from fertilization first, and then some pending questions were there from Unit 1A and 1C, which we had covered before. So I'm going to discuss those as well today. Okay. So these are CSIR NET question answers, as you would already know. All right. The first question. Several marine organisms release their gametes into their environment, where sperm attraction and subsequent events lead to successful fertilization. So, with reference to sea urchin, which one of the following statement is not true? Now, in the class also, we had seen about this fertilization in sea urchin only, right? So, here are your options. You can answer. Yes, very good evening, Kirtana. So, today we are discussing some questions from Unit 5 and from Unit 1 also. So we have seen about the chemo attraction part, isn't it? This question covers topics of chemo attraction from fertilization. That is the first step when sperm will be for meeting towards the egg. Okay, and the rest of the parts is for block to polyspermy. Yes, that's right. They've worth. It is for life science, CSIR NET. We are discussing question answers over here. CSIR NET life science. That's right. Yes, come on, students. You have to select the wrong statement from here. So you can at least tell me which options you are sure of. 1, 2, 3, 4, that it is correct. You can tell like that also. Not necessarily you have to answer it only incorrect statement. You can do, however, it will be easy for you to answer. Okay, Sunshine, let's see. We'll wait for others also to finish answering. Yes. See, at least you should try. Don't be afraid of giving wrong answer or anything. We are not punishing you or taxing you or anything, right? If your answer is wrong. So when you answer, what happens? The moment I tell you the right answer or the explanation, your brain registers, oh, okay, this is the correct answer. I had answered it wrong. Okay. But when you don't answer at all, when I say the correct answer, it doesn't matter to you. Okay, your brain doesn't register much in that one. When you are answering, that time it is very important that your brain should know, okay, this is not the right answer, this is the correct answer. So always when you are attending this questions answer session, whichever you feel is correct according to you, you can answer that. Okay. Okay, Anusha, very good. Sure of 1 and 2. That is absolutely right. Okay. So see here it is saying addition of Resact into a drop of seawater. Okay, yeah, we'll see. Okay, Yusra, let's see. So seawater, you remember there are ions in that, right? Sodium chloride. So sodium ions are there. Now they contain sperm. Specifically, they attract sperms of Arabica punctata. So this is a species of sea urchin, correct? Now we know that definitely the Resact is what? So Resact is a chemoattractant. I mentioned you before, right? Resact is chemoattractant. Now what is chemoattractant? It is released from the egg. Okay, so they are like some soluble factors which is released from the egg, and the sperms which are traveling towards the egg, okay, they will sense the concentration gradient, because from the egg if it is released, then it will diffuse from the source of the egg, but more concentration will be towards the egg. So this is the egg. Okay, these are chemicals which will be able to attract the sperm and make them flow towards the egg. Okay, so there will be that movement in the sperm flagella, the tail. What is there? There will be a movement in that, and they will swim more faster towards the egg. All right. So yes, that is right. Because if you have the sperms, if you add a drop of Resact, okay, so that is acting as a chemoattractant, and the sperms, they will have a change in their cellular response. Okay, so that is a G protein GPCR mediated signaling process which is triggered in the sperms. I'll show you what is a signaling step. So that GPCR signaling is triggered in the sperm and allows them to flow towards the chemoattractant. Okay, so this is a correct statement. Now, second statement, IP3 is formed initially at the site of sperm entry and releases sequestered calcium. Now, in the cytoplasm, you must know, so in the cytoplasm, there is a low level of calcium initially. Only when the fertilization happens, only when the sperm will fertilize the egg, okay, from that side of the egg, calcium ion starts increasing. Okay, now why that calcium ion is there? Because these here some receptors are there which gets activated. Okay, so those receptors activate enzyme that is phospholipase C. I'll show you there, and they will break a molecule called as PIP2 into IP3 and DAG. Okay, so that that IP3 can release the calcium from the endoplasmic reticulum. Okay, we have the endoplasmic reticulum which is storing calcium inside it. So from there the calcium will be released. Got it? Now this calcium travels as a wave. It doesn't uh, travel through the entire cytoplasm altogether. So in one part of the egg it will increase, then in the next part it will increase, then again in the next part. So like this it will travel as a wave. So when it is increasing in one part, the other part of the egg will not have calcium. Okay, so if the other part, next part is having the wave, then the previous part will not have the calcium. Okay, it is from the endoplasmic reticulum, Anupam. Okay, so we have the IP3 which is formed initially at the site of sperm entry, and sequestered means hidden, the ones which are enclosed somewhere. So those are released. Okay, and yes, IP3 is formed there itself at the site of sperm entry, because that's the point where the cell signaling is initiated or triggered. Okay, so this is the right answer. Means this is also correct statement. Calcium prevents docking of cortical granules of the egg to the cell membrane. Now, calcium, which is now released into the endoplasmic reticulum, we know that just under the cell membrane, you have these cortical granules. And when the sperm binds, these cortical granules will release their contents. So, how they are releasing their contents? And they will release the contents outside this plasma membrane. So, outside the plasma membrane, you have a vitelline envelope also. Okay, so there it will be releasing the contents of the cortical granule. This process is called as cortical granule exocytosis. Exocytosis means throwing out of the cell. Okay, so that our our entire cell signaling, because of which calcium is triggered, calcium actually acts as a very important secondary messenger. So messenger will do what? It will take the message, isn't it? So according to the cell signaling, calcium gives the signal that the changes or responses should start taking place. What responses? That the sperm has entered and we should not allow any more sperms to enter again. So it's actually a block to polyspermy. Got it? So calcium only triggers this exocytosis of this cortical granules. This is the reason why these are releasing their contents outside. Okay, so but it is written calcium prevents, which is absolutely wrong. So this is the wrong statement. Okay, this is not correct. Okay, now inhibitors that specifically block PLC gamma. So before this, let me just show you what was there. Yes, so Sunshine and Surinder, your answer is absolutely right. Okay, so we'll look once again. This is what is resect. As I said, it is released from the egg. So the jelly layer is there from the egg. Okay, from there it is released, and the sperms will come and bind to the jelly layer. That is the outside coating. Now there is a change in resect. Okay, there are some nanomolar range changes in the resect. Uh, it can sense even minute concentrations of resect, because of which when it binds to the receptor on what? On the sperm or on the egg? So this resect receptor, where do you expect it to be present? On the sperm or on the egg? Yeah, everyone is wrong. Everyone is wrong. Why? Why will it be on the sperm? Why will it be on the egg? Who is releasing the resect? Tell me now. Who is releasing the resect? See, you should be very much careful while answering such kind of questions, okay? Who is releasing the resect? And in the diagram also it is shown. Yes, Ashu, that's right. Yes, can you tell me? Sunshine, Anupam, Aishwarya, Anusha, Yusra. From where is the resect released? So who is attracting whom? Egg is attracting sperm, isn't it? Then, so result will be released from the egg and it will be sensed by the sperm, isn't it? So sperm will have the receptor. You should apply some common sense, okay, while doing the question, right? So sperm will have the receptor. The receptor gets activated. What type of receptor it is? Guanylate cyclase. So I was telling you, know, this receptor, it is a type of a GPCR. Any sensing processes when it is there, okay, like example our eye, our ear. So generally this kind of sensing type of signals, it is received by GPCR category of receptor proteins. We have tyrosine kinase receptors. Different type of receptors are there, isn't it? So this is a GPCR type, which is associated with a guanylate cyclase. It's an enzyme. So what does it produce? It produces cyclic GMP, okay, which acts as secondary messenger. So cyclic GMP increase, and that in turn increases calcium concentration inside the what? It will increase calcium concentration inside what? Yes, that's right, Anupam. Inside the egg or inside the sperm. So receptor is activated, CGMP is increased, and that CGMP is causing increase in calcium concentration in what? What is wrong with you people? So if you have the sperm, let's say I'm drawing a big one, okay? You have the sperm, right? So the resect molecules, it is binding to the receptor on the sperm. So here only you will have the guanylyl cyclase, right? Then the guanylyl cyclase will release CGMP in the sperm only, no? How it will release in the egg? Then CGMP will take out the calcium in the sperm only, no? Got it or not? Why you people are saying egg? How difficult is this to understand? Egg is releasing the resact. It is releasing the chemoattractant. Sperm is receiving that chemoattractant. Okay? Alright, fine. Fine, Ashu. So it is releasing that receiving the chemoattractant sperm, and all this signaling process. These are all signaling process. Okay, when you learn unit 4, then I think this part will be very much clear to you. Okay, so for cell signaling, there is always a cell which releases signal, and there is a cell which receives the signal. Okay, so whatever responses are happening, it will happen in the cell which receives the signal. That is why it is called as a responding cell. Okay, responding cell. Okay, yes, receptor is on sperm, so calcium will be released in sperm only. Yes, that's right, correct, Anupam. So then the calcium increase will be triggering the flagellar beating. Flagellar beating, asymmetric beating will be there, which will be having a change in the swimming direction. Okay, so upon fertilization, the calcium ion concentration increases, which causes the cortical granule to fuse with the egg plasma membrane, releasing their contents. As a result, a wave of cortical released from the uh, endoplasmic reticulum, a wave of, so sorry, this will be a wave of calcium. Okay, so a wave of calcium released from the ER, okay, not from the mitochondria. Mitochondria is powerhouse of the cell. ER is what stores the calcium, okay, begins at the point of fertilization and travels completely around the egg. Okay, so it goes as a wave. That's why option is incorrect. So this is the cell signaling process which is there. Mind it, this is in the sperm. Okay, this is the sperm, this cell, sperm cell. Okay, and this is the plasma membrane. Okay, plasma membrane of the sperm. Now you have some receptors are there. Okay, no, so sorry. Okay, no. Please excuse me. That was about the chemoattractant. Now we are discussing the second part of it. Okay, I'm very sorry for confusing you. So that part which we discussed now till now GPCR, that one is for chemoattraction. Okay, keep that separate. Now we are discussing this second part. Okay, the second part we are discussing regarding the slow block to polyspermy. Okay, we are discussing the second part, slow block to polyspermy. Okay, so what happens here in the slow block to polyspermy? This is actually the egg membrane. Okay, this is the egg membrane. Fine. Now I mentioned that when the sperm comes and binds to the egg, okay, when the sperm comes and binds to the egg plasma membrane, it will fuse with it. It releases its contents inside. So these contents are released outside. Fine. Okay. But when the sperm binds, what happens? Some receptor is triggered. Okay. The sperm binds, some receptors are triggered. Some tyrosine kinase receptors. They are associated with this enzyme phospholipase C, which is called as PLC gamma. Actually, phospholipase C, there are several types. Phospholipase C A1, that is alpha 1, then you have beta 1, then you have sorry, not beta 1, you have alpha 2, then you have delta, phospholipase delta, then you have phospholipase gamma. So, this is what you have in your diagram. This is actually a phospholipid. Okay, this phospholipid name is IPIP2. Why it is PIP2? How are phospholipids made up of? They have a glycerol backbone. So see, this is a glycerol backbone. From here, one fatty acid comes out from first carbon. From the second carbon, another fatty acid comes out, which are a part of the cellular membrane of the egg. Okay. The third carbon, however, is associated with a phosphate group, and that phosphate group is further associated with a polar group. Now, this group is what is called as a inositol. Okay, this group is a inositol. It is a polar group. Okay, now this polar group is already phosphorylated at two of its position. One is here, another one is here. Okay, and phospholipase is, it actually cleaves in a particular place in this phospholipid. So I was telling you, alpha 1, alpha 2, delta, they cleave at different places. Like alpha 1 cleaves it here, alpha 2 cleaves it here, okay, delta cleaves it here. But where does our phospholipase C gamma, where does gamma cleave? So that's why I was mentioning gamma. Gamma will cleave it here. Okay, PLC gamma will cleave the phospholipid here. So when this happens, this entire molecule is separated from this molecule. Now, what is this molecule which is remaining? This was a glycerol backbone. Two fatty acids are there along with it. So, glycerol backbone along with that fatty acid means it's called as acyl group, okay? And 2 means it is di. So, diacyl glycerol. And this one, it is inositol molecule with already 2 phosphate. Now it has a third phosphate. So, it will be IP3, inositol 3 phosphate, okay? This inositol, now here you have a endoplasmic reticulum. This inositol goes and blocks or binds, not blocks, binds to the receptor. This is actually a channel. What channel? Calcium channel. Okay. So this IP3 will come and bind to this channel. It is a ligand gated channel. That means only when some ligand will come and bind, then only the gates will open for this channel and the ion can go out. Okay, that's why it was written sequestered calcium, which means it was enclosed within the endoplasmic reticulum. In cytoplasm, initially concentration was less initially. Okay, but later when this IP3 was released, now from why it was released? Because of PLC gamma activation. Why PLC gamma activation was there? Because of sperm binding. So already one sperm has fertilized the egg. We don't want any more sperms to bind. That's why the cortical granules which are present under the plasma membrane, they should release their contents so that the vitelline envelope which is there on top of the plasma membrane, they can lose their receptors and should not allow any more sperms to bind. Okay, so that's why this calcium goes and triggers the cortical granules to undergo exocytosis. Along with that, it also activates something called as sodium proton exchange pump. Okay, in which the sodium comes inside and protons they are going outside. Okay, so if proton goes outside, the outside will be acidic, but inside will be alkaline. And because of this alkaline nature, the rest of the metabolism of egg, till the sperm had fertilized the egg was inactive. But now the egg has to be activated. So this metabolism of egg is triggered by the alkalinity inside the cytoplasm. This leads to egg activation. Okay, is everybody clear with this response of the egg upon binding of the sperm? Yes, everyone is clear. See, questions generally come from this topic. Okay, most often you will find questions like this. You will see, I'll be discussing 4 5 questions from this topic now. You will understand how it is important. Okay, so please remember this part. Now, what was the last statement? Last statement was inhibitors that specifically block PLC gamma, right? So if PLC gamma is blocked, then this entire signaling pathway is not possible to happen. Because if PLC gamma is blocked, even if sperms comes and binds, it cannot activate it. If it cannot be activated, IP3 cannot be released. Okay, but there an IP3 cannot be released means calcium will not be there, cortical granule will not be there, nothing of all this will be there. But if you use a IP3, if you micro inject IP3 into the egg, means you are blocking the PLC gamma, but in turn you are micro injecting IP3 into egg. Okay, so this is blocked. You cannot get IP3 from here, from PIP2. No, but separately IP3 is injected. Separately, you are injecting IP3 from outside source. Then what will happen? Doesn't matter if it is getting from inside the cell or not, it will still go and do its job. It will still go and bind and it will release the calcium. Okay, so it can be circumvented, means it's a workaround. It's another way of making this happen. Okay, so that's why this statement is also correct. If you have inhibitors that block PLC, that can be overcome. in very simple word means it can be overcome. The result can be overcome if you simply microinject IP3 into the egg. Still, it will allow the fertilization responses to take place and the egg will be activated. Okay, yes, it will work. Correct, Anupam. So I hope this question is clear. Okay, that took a lot of time. We should move forward. Okay, this is your second question. Now see this is again part C question. Okay, as I told you, these are very important topics, and yes, you do get some important questions, part C questions from here. I think the previous question was part B, and it was from November 2020 CSIR exam. Okay, and these further what I'll discuss, these are part C questions only. So I can say that this is an important topic. So fertilization again in sea urchin. We generally get question from fertilization in mammals or fertilization in sea urchin. Again, mostly we get from sea urchin only. So see, we were talking about the different chemoattractants and then fusogenic proteins in class, if you would remember. So we had a fusogenic protein called as bindin. Now, where is bindin present? Bindin is present on the, so we have the plasma membrane of sea urchin, okay, and then we have the egg membrane of sea urchin, right? So bindin is present on the plasma membrane, okay, and receptors for bindin are present on the egg plasma membrane, okay. Bindin that is present on the sperm and receptors. So receptors of bindin are present on the egg. So what type of a molecule is this? This is a fusogenic protein. It helps in the fusion of the sperm plasma membrane and the egg plasma membrane. Okay. What is the option about? It is for unfertilized or fertilized? Both. So it is asking that after fertilization what happens? Like after 1 to 3 seconds of fertilization. Okay. So I just wanted to tell you that the receptor name is EBR1. So bindin is the fusogenic protein and EBR1 is the receptor name. Okay, remember that, which is on the egg. It can be confusing because you have 2-3 processes and you have to know which is the which is releasing the signal, which is receiving the signal. Okay. For example, chemoattractant is released by the egg, it is received by the sperm. But in bindin protein is present on the sperm, but it is received by the egg. As in, it is not released. It's just binds with those receptor. Okay, and EBR1 is called as the receptor of binding. Fine. So the question is asking, fertilization in sea urchin involves interaction of sperm binding with the receptor EBR1, a 350 kilodalton glycoprotein on the egg vitelline membrane. So the plot given shows status of membrane potential and levels of EBR1. This one is given for a unfertilized egg. Okay, Anupam. See, it's mentioned in the question. These are actually your options. Okay, 1, 2, 3, 4. These are your options. This is already part of the question. This is in an unfertilized egg, and these options what they are showing is after fertilization. When? After 1 to 3 seconds. Okay, after 1 to 3 seconds of fertilization, these are the options. So out of this, which is correct? Now this is a two things are shown in the graph. Okay, so the one part of the graph is about the membrane potential. We know that across the plasma membrane we have a potential difference. Inside part is minus 70 millivolt. Okay, inside part is negative. Now, with respect to time, how much the membrane potential is increasing. So that is showing here in this graph. And the second part of the graph is showing the concentration. Okay, concentration of several things, which is given in the key. That black, the white part, the unshaded bar is for EBR1. That is, this much receptor is present. Okay. The shaded bar is for sodium ion. So this much concentration of sodium is present in unfertilized egg. And this dashed bar, it is for potassium, which is present in this much concentration in unfertilized egg. So in fertilized egg, which out of this will you see? So you have to observe a lot of things at a time. You need to answer it very specifically. Got it? Okay, Anupam, let's see. Why none of you are answering? See, I told you, no, you should at least try to answer. If it is wrong, I will tell you. Okay? No need to worry on that. Okay. So let's see. Confused between 2 and 3. 2, most of you are saying. Absolutely right, Anupam. Your answer is correct. Okay. Yeah. So Anusha, Sunshine. Yes, option 3 is correct over here, students. Now, why option 3 is correct? Because, see, let's discuss this part first. That is sodium entering inside the egg. So what happens is, so as I told you, which of the following graph best represents the condition within an egg 1 to 3 seconds after fertilization. Okay. So this is the egg membrane. Okay. Inside, this is outside, and this is inside the egg. Right. So inside, as we know, initially the potential is negative. So you have minus, negative potential is there. Okay. Now what happens from outside? Sodium will come inside. Got it? When will that happen? The moment a sperm will fertilize the egg, like the moment the fusion takes place, one sperm plasma membrane and egg plasma membrane. The moment the fusion takes place, immediately the sodium channels. So there are channels, okay, in the egg membrane. That sodium channels, they will open up. Okay, and the sodiums they get inside. Now sodium is positive charge, correct? So sodium more positive charge. Once it is there, what will happen? These negatives, they are neutralized by more positives. So initially it will be negative, but later it will become neutral. Okay, only initially it will be negative, later it will become neutral. So this ionic imbalance is maintained by membrane pumps exchangers Ionic imbalance creates electrical potential across the membrane. Minus 70 millivolts sperm binding causes sodium influx. 1 to 3 seconds after sperm binding, membrane potential shifts to plus 20 millivolt. Got it? So it will be shifted to plus 20 millivolt, means it becomes positive. From negative, it becomes positive. Got it? So that's why this graph is showing. If you see over here, this graph, initially it starts with minus 70. But later what happens, you can see here you added the sperms. Immediately you don't see, but after the sperm enters the egg, because sperm has to enter the egg also. No, you just added the sperms where the eggs are present. So once the sperm enters the egg, from there the rise will be there. Rise in potential difference. Before the addition of sperm, the potential difference across the egg cell membrane is about minus 70. Within 1 to 3 seconds after the fertilizing sperm enters the egg, the potential shifts in a positive direction. Okay, and from there it will slowly come down. It will not remain like that. It will slowly come down also. Okay, so inside is minus 70, but after sodium gets inside, it will become positive. So you can see here that in this graph, it is showing that from minus it is going to positive, and then it is coming down. So these two are correct. It does not go down definitely. You can see here it is going down. It does not go in steps also. It goes directly, like very immediately it goes up the concentration. Got it? Now out of these two, this is which one is correct. For that we need to see the sodium. So just now we saw that this is sodium which is entering. So initially sodium is less inside the egg, right? But after that you see the sodium concentration is increasing. See, there is no reason for EBR1 receptor to decrease in concentration. So it remains the same. Like it's a receptor. Why will it decrease, right? Yes, it will be inactivated later because as a block to polyspermy, but not within 1 to 3 seconds. Okay, but it is saying 1 to 3 seconds. That is why and moreover it's a receptor, it will still be there. It will just be inactivated. So here concentration remains same. Potassium changes are not there. It remains the same because it does not go out also. It does not get in also. Okay. Only sodium concentration changes. So option 3 is the right answer. Did everyone get this part? Is it clear for everyone? This particular question. So this is a fast block to polyspermy. Why it is called as fast block? Because it happens very fast. Okay, very fast means immediately after binding of the sperm to the egg, it will immediately block this one. Okay, Sayanti, when did you join? So if you have missed the previous part, you can just watch the recording. If you have any specific doubt, you can let me know. Okay. Okay, fine. Sunshine, Yushra, Ashu, Anusha, it's clear for you. Fine. Uh, okay, next is question 3. So this one you may or may not answer because we haven't covered mammalian yet. So we'll do one thing. We'll just keep this question as of for now. We'll discuss it later. Okay. You can just answer this question. If we get time, we'll come back to it. So here we have 3 embryos, X, Y and Z. So what are these embryos? These are actually Drosophila embryos. Okay, we had studied about morphogen gradients, remember? So morphogen means what? In the Drosophila, you have some gradient, right? So this gradient is there. In the anterior bicoid gradient is there. Even last class I told you. In the posterior, you have nanos gradient, isn't it? So bicoid is more dominant. Wherever it is present, it can develop head-like structures. Okay, and in the posterior, you have these nanos. These are morphogen, and they will be specifying different areas of the embryo depending on the concentration of these morphogens. Okay, yeah, Anupam, Priyanka, let's see what will be the answer. So we have three embryos. So when you get this type of questions, better always to draw it and see. Okay. So you have this wild type, which is we can write as WT only, wild type. Okay. Then we have this mutant for bicoid. So that is B minus. And then you have another one which is mutant for nanos. Okay. Now in all of them, first understand where will head develop, because this question is asking about where head will be developing. Okay. So wherever bicoid is there, their head will develop. So for X, it is wild type, head will develop here. Okay, like in the anterior part. So I'll just write as head. Mutant for bicoid, head won't develop. Here head will not be there. Okay, and nanos will develop the other structures as it is, right? Mutant for nanos. Now nanos is not there, but bicoid is there. So here also bicoid head will be present. Okay, because of bicoid head will develop. Okay, obviously at the posterior bicoid is not there naturally, so it won't be making head in the posterior. Even though if nanos is not there, so nanos is making abdomen. That's why abdomen won't be there. But bicoid is there means it will only develop head wherever it is present normally. Now you are injecting bicoid mRNA in the posterior pole, okay, at early cleavage stage. Okay, so when you are introducing bicoid mRNA in posterior means over here. Now, wherever you're introducing bicoid, nanos, if it is there or not, it will develop head. So here also it will develop head, here also it will develop head, here also it will develop head. Because in all of them you're introducing at the posterior pole only at early cleavage stage. At early cleavage stage means where nanos has not yet been able to specify. Nanos is there, but it has not still specified the nucleus present over here. So at that time itself, if you put bicoid, then it will overrule the nanos and it will make head in its position, right? So that's why you can see embryo X and embryo Z has formed head, two head on both sides. Okay, on both anterior and posterior, but embryo Y will develop head only on the posterior. So it's an easy question. It's actually from Drosophila development, but just because we have covered morphogens in our topic, syncytial specification, and we also know about the bicoid and nanos, that's why we discussed. And very good, most of you answered correctly also. Yes, Anupam is right. Priyanka, Saujanya, did you get it now? Yes, you have answered it later also. Yes, Anusha right. Surender correct. Sunshine also. Very good, everyone. So this is what I mentioned. The bicoid is giving rise to head and thorax. Abdomen is given by nanos, right? So in bicoid mutant, you will not have the head thorax area. In nanos, see how small this is. You don't have the abdomen area, but bicoid and head and thorax is still there. Got it? And torso is for the tips that we will see later in class. Okay. So this mutational type of questions are very common in developmental biology, unit 5 questions. What is the effect? What is the effect of different mutations in the maternal gene system? Okay. Okay, then there is one more question about this fertilization only. So try to answer this question also. You still remember somehow? Okay, that's very good, Anupam. Continue like that. Okay, so let's discuss the answer. We'll see if answer is correct or not. Anupam and Sunshine. So just now we had discussed about it, isn't it? So you must be able to tell something at least, correct? Sure with AB. Okay, Anusha, very good. Let's see. So you're sure that A and B is not true, right? So see here, Resact and Spiract, they are peptides. Yes, very good, Saujanya. That's the right answer. Okay. So, and I just want to confirm, Anupam and Sunshine, did you mean C? Like you have said option 3, or did you mean only D? Because sometimes you we tend to think like that, okay, that no, C is not correct. So we will tend to write 3 because C corresponds to 3. Like that we might think, okay. So generally we have to be very careful about these things. Okay. So C is not correct means you have to mark only C. By in Haribari, we might mark like that. Got it? Yes. So this is the correct answer. I thought so. Yes, yes. Sunshine, I understand. Okay. Fine. Okay, Anupam. Yeah. Saujanya Surinder, very good. Your answer is right. Yes. Yusra also right. So Resact Spiract are peptides which are released from the egg jelly and help in sperm attraction. Okay. So this I already told you that the chemoattractants are released from the egg jelly layer, right? And they will help in attracting the sperm towards them. This is correct. Bindin is an acrosomal protein. That's right, because acrosome is present on the sperm and binding is present on the sperm. Correct? It interacts in a species specific manner with eggs. I told you for this also that the binding um, um, will be present on the sperm and it will interact in such a way that only the sea urchin sperm will be able to fertilize the sea urchin eggs. Okay, so it is interacting in a species specific manner with eggs. Then we have C, which is a respiratory burst, occurs during cross linking of fertilization envelope where calcium dependent increase. So, see, I told you in class also that when the egg is activated, when egg metabolism is triggered, the respiration suddenly increases. Okay, and the oxygen gets consumed. If you see over here, these are the late responses inside the egg. Inside the egg, these are getting triggered. So activation of NAD kinase, early responses are also there. So early responses are your blocks to polyspermy, the slow block, the fast block, and these are late responses. Okay, activation of NAD kinase, increase in NADP plus, NADPH, increase in oxygen consumption. That only means that respiration is increased. Okay, I also told you that alkalinity increases, that is increase in pH. Acid efflux, efflux means going out of the cell. So I also told you H plus goes out of the cell, correct? And apart from the other things, like the cell will prepare for its first cleavage division, sperm nucleus will fuse with the egg nucleus. So all this happens slowly once the slow block is established inside the egg. Okay, so after the sperm egg binding, yes, we have the fast block to polyspermy, then phospholipase C activation, IP3 calcium, cortical granule exocytosis, slow block. So all this will be taking place when the consumption of oxygen will increase. Okay, but see what is written. So this part is correct. Fertilization, a respiratory burst occurs during cross-linking of the fertilization envelope. This part is correct. But what is there where a calcium dependent increase in oxygen level is observed? If respiration is happening, how will your oxygen level increase? Isn't it? So it is calcium dependent also because all this process is achieved by calcium increase inside the cytoplasm only. But how will it cause an increase in oxygen if respiration is happening? Because it will be aerobic respiration only, correct? So only word which is wrong here is increase. It actually should be decrease. Okay, right? So this is wrong. Fourth is right. IP3, which is formed at site of sperm entry, that is also correct. Sequesters calcium leading to cortical granule exocytosis. So actually IP3 pulls out the calcium. That way it is written sequesters. Okay, means it binds the calcium, means it makes the calcium come out of the endoplasmic reticulum. Okay, so ideally what I feel is that instead of this, it should be releases sequestered calcium. Okay, releases sequestered calcium. Sequestered calcium means which is enclosed. IP3 releases that calcium. Okay, so probably they missed out one word, releases, but still, since this is a very major mistake, so we will mark with only C. Okay, so here one word is only missing. That's why technically this statement is not correct. All right. So generally, when you see such questions, it is better to avoid. If you feel like some doubt is there, you know that it is not sequester, so you better leave that question. Fine, because there is a 50-50 chance that they can accept that mistake or not, because some proof has to be given or something. Later they might accept or not accept, so it's better to avoid. If they are accepting, means you will get benefit of marks advantage, but if they are not accepting, then simply you will. Yeah, I understand, Anusha. Okay, so this even I feel it's not 100% correct, option D, but compared to option D, C is technically, means C is majorly wrong. So that's why let's go with only C, because C and D both option is not there. Okay, but this choosing will require a lot of experience. So at your level, you won't have the time to decide also. So better leave such questions. Okay, if you don't have anything else to answer and you still have to finish 25 questions, then you can come back. Okay, we have less time left. Quickly, let's discuss two unit 1 questions. Okay, so one is regarding the solubility. This is from unit 1A. So solubility of NaCl is greater in water than ethanol. This is a very recent question. This is the one which happened recently from the recent exam. What physical property of the solvent governs this distance? So the trick over here is here, right? You want to tell what is the property of the solvent, means you're talking about ethanol, right? You're not talking about NaCl. So what are your options? Surface tension, viscosity, dielectric constant, and boiling point. Which will be your option? Solubility, you will find obviously NaCl is ionic bond. We know that ionic bonds are present in the form of lattice, correct? They are present in the form of lattice. And ethanol will consider non-polar solvent, right? Non-polar solvent. Correct? Yes, very good. Sunshine, Ashu, that's the right answer. So here the option is dielectric constant, right? So I told you in class itself, this is this is actually a term in physics. You don't want to go into detail of this term. So dielectric constant actually represents the polarity. Okay, so if it is more, it means it is polar molecule. Like for water, the dielectric constant value is 80. Okay, so it is considered a more polar molecule. Fine. And ethanol, its dielectric constant is less. So ionic bonds, which are basically joined by electrostatic attractions. So electrostatic attractions and polar molecules, they will be having interactions, good interactions. So NaCl will be having more solubility in water, okay, but less in ethanol, because ethanol's dielectric constant will be less. So that's why this is the answer. Fine. So solubility of ionic compounds, yes, Anu, that is right. Good. Yes, Anupam also correct. Did you get Sayanti? Yeah, Kavita also right. Solubility of ionic compounds like NaCl depends on the ability of the solvent molecules to interact with the ions. In the case of NaCl, the sodium and chloride ions dissociate in water due to its high dielectric constant. So it's actually a measure of a solvent's ability to reduce the electrostatic forces between charged particles, right? Because the solvent, only if it is able to reduce the force, then only it will be able to separate out the ions. Okay, so water has a high dielectric constant, and when it is able to separate out the ions, then only it will become soluble. Water is able to reduce the electrostatic forces between Na and Cl. Got it? So it means it can effectively solvate the ions and stabilize them in solution. But ethanol has a lower dielectric constant, around 24, right? And it compared to water, so that's why it is less. This low dielectric constant of ethanol makes it less effective in solvating the ions of NaCl. As a result, NaCl has a higher solubility in water than in ethanol. Okay. So Anusha, unit 1 is not started in morning session, it is started in evening session. But what you people can do is, if you are a biotechnica student, morning batch may be able to see evening batch classes also. And evening batch may be able to do that also. Okay, so in my sessions, I will be discussing unit 5 questions some days, unit 1 questions some days, as and when the classes are going. Right? So what I suggest is that why to wait, simply why to wait for the classes to finish, right? So why don't you try it on your own? You just keep going with the recordings, okay, in case you want to. Otherwise I will be teaching you later also. So next question I'll go for, yeah, on a molar scale, which of the following interaction in a non-polar environment provides the highest contribution to the biomolecule? So on a molar scale, here the trick of this question is in the non-polar environment. So in the non-polar environment, which will provide highest contribution? Okay. So it is in a non-polar environment. If it is in a polar environment, you think about it, many of you are saying hydrophobic interaction. But if it is in a polar environment, that is aqueous solution, in aqueous solution it is there, right? Then the protein is folding means what? They will be, yes, that's right. Surinder, that is right. Correct. See, lipid bilayer, what is the environment they are folding in, Anupam? It's water nearby, isn't it? That is why the hydrophobic interactions, they are facing each other. The tails are facing each other. So here you have hydrophobic interaction. Yes, it is stabilizing. Hydrophobic interaction is maximum. But when it is in the polar environment, that is why they want to avoid the water, isn't it? So it is talking in non-polar environment. So here your answer will be Van der Waals forces. Okay. This is according to me. This is a pretty old question, I feel. I don't quite remember which year this was, but not much old, but yes, it was like back in 2016, 15 or something like that. Okay. Or probably 14 also, probably. So I don't have the CSIR key. They don't have it in the website. Okay. So I don't know what CSIR had given the answer for. Okay, but according to me, it should be Van der Waals interaction. That is why here I didn't mark the answer. Okay, I just left it like that. So yes, this is a confusing question. Means I don't know the exact key, but I just want to rationalize what the answer should look like. Okay, see, in my understanding, hydrogen's bonds are associated with water because hydrogen bond will be forming in presence of hydrophilic environment. Salt bridges are also electrostatic in nature. So only when you have a polar environment nearby, then only they should form. And moreover, salt bridges and are not formed with everything. Even hydrogen bonds also. You require a specific donor, you require a specific acceptor, then only hydrogen bonds will form. On the other hand, hydrophobic interactions are also a result of repulsion from hydrophilic groups. So, hydrophilic groups prevent the phase separation of the molecule by maintaining the hydrophobic groups in water through formation of some strong hydrogen bonds with water molecule. So, this driving force for this assembly is what is called as hydrophobic effect. Okay, but Van der Waals forces are the only interactions that provide highest contribution as they are only driven by induced electrical interactions between two molecules. The two molecules, they will just come close, they will attract, they will go out, they will repel, they will have repulsion. It doesn't depend on the polar and non-polar environment. Okay, it is between two molecules. So I think in a non-polar environment, Van der Waals should stabilize the biomolecule most. Okay, so that's all for today's class. Thank you everyone for joining in. So was it helpful? Was this class helpful? Did you learn anything new over here today? Or did it help you in understanding the previous concepts? And will it be beneficial for you to remember concepts for upcoming exams? Yes? So we are discussing in class and then we are discussing questions here so that our students benefit from that. Okay. Okay, that's very good to know. Thank you everyone for joining in. So I'll see you later in another session. Okay. Thank you everyone. Yes, it was like a revision, correct.